For our project, we are talking about stem and leaf plots, a topic that was discussed in the very first unit of AP Statistics. A stem and leaf plot is a special table where each data value is split into a stem and a leaf. Explained later.
Stem and leaf plots are used for univariate numerical data and are mostly used for small to medium-sized data sets. Additionally, every stem has to be listed from the smallest to largest value.
Each data set is split into two parts. One, the stem, which is for the first number of numbers, and two, the leaf, which is for the last number.
A really good example to use would be the number of pencils used per student per year.
This is univariate numerical data that can be easily recorded using a stem and leaf plot.
Man, that is a lot of pencils.
Stop killing the trees. Looking at this example, it should be easy to describe the distribution of number of pencils. Most of the scores are clustered between 20 and 30 pencils, with the center falling around 30. The scores range from a low of 10 to a high of 61. Once the data is recorded onto a stem and leaf plot, a key should always be included for easy understanding. Here, 1 line 0 is 10 pencils. If datasets have a really long list of leaves behind each stem, it would be a lot easier to split the stem into high and low. An example would be recording the bio test grades at Plano West.
Wow, I think bio needs to study more. If you're planning to split one of the stems into high and low, make sure you split all of the stems.
In these examples, the stem and leaf are explicitly labeled for educational purposes. In the real world, however, stem and leaf plots do not have these stem and leaves labels. In this particular example for bio test grades at Plano West, you can see that the numbers are clustered around 71 through 79, and the center lies around the high 70s.
For this example, the key basically works the same way. 8L line 0 means 80, while 9H line 6 means 96.
There's another type of stem and leaf plot called comparative stem and leaf plots, also known as two-sided stem and leaf plots. In these, two sets of data are recorded on the same graph using the same stem but different leaves. For example, boys and girls' heights in centimeters. It is always important to remember that these types of stem and leaf plots should only be used when you want to compare two different sets of data. Additionally, it is always important to remember to use comparative language when doing so. After the stem and leaf plot is finished, we will be able to see different trends on each side of the stem and leaf plot for girls' and boys' heights. We will also be able to find the mode, range, and approximate the median. Here you can see the stem being split into two leaves, one for the girl's height in centimeters and one for the boy's height in centimeters. There were three modes for the girls, 155, 170, and 176. The range was 26 centimeters and the median was approximately 170 centimeters. For the boys, the mode was 167, 170, and 185. The range was 20 centimeters and the median was approximately 172 centimeters.
With this particular dataset showing boys and girls' heights in centimeters, the boys' heights are skewed right, while the girls' heights are skewed left. To see the skew, you can always turn the stem and leaf plots sideways.
As always, a key should be included for easy understanding of the stem and leaf plot. Here, the drawn stem and leaf plot shows that boys' height is 165 centimeters and girls is 168 centimeters. Another topic that should always be discussed when dealing with stem and leaf plots is truncating, which is shortening a number to make it easier to record. Here, 46.7 is truncated to 47.
Man, that was a long video.